It's a pleasure to be invited to the first ACE Forensic Engineering Conference. Thank you for the invitation. Today, the topic of my presentation is digital transformation and tomorrow's smart water plants. My name is Subir Bhattacharjee. I am the CEO of IntelliFlux Controls Incorporated. The outline of the presentation is as follows. I'll provide a brief overview of IntelliFlux Controls. We will discuss the digital transformation steps, particularly how IntelliFlux implements digital transformation, and talk about two components of our technology, namely digital twins and the artificial intelligence, machine learning, and predictive analytics that we use. I'll describe some applications and use cases in wastewater treatment and seawater reverse osmosis, and then I will conclude with some remarks about autonomous plants and smart plants of the future. IntelliFlux Controls was established in 2017. We specialize in digital transformation, operator support, automation, and real-time optimization of water treatment and chemical processing plants. Our enterprise software platform, Apricot, is used by our customers to achieve OpEx savings, reliable operations, and improved plant performance. We provide our customers about $500,000 of value per plant annually. We improve the efficiency of the plants. We provide OpEx savings. We have about 45 projects around the world. And the technology was the winner of the Technology Idol at the Global Water Intelligence in 2016. And we were the finalist as a startup in Imagine H2O's 2018 Accelerator. The software platform that we developed is called Apricot. It stands for Automated Process Recommendation and Industrial Control Optimization Toolbox. It's a platform delivering process wisdom in real time. The product is delivered in 3 tiers. One is Apricot Connect, second Apricot Assist, and third Apricot Operate. IntelliFlux helps our customers in municipal, oil and gas, food and beverage, textile, chemical processing, various segments of the process industry to achieve water footprint reduction, energy footprint reduction, waste volume reduction, OpEx savings, helps with water reuse, and technologically what we do is process intensification or improving the efficiency of existing process plants. The steps that are involved in IntelliFlux engendered digital transformation are as follows. The philosophy of IntelliFlux is based on closing the IDKW loop. IDKW stands for information, data, knowledge, and wisdom. So what we do is we collect all the information from the plant that are embedded in its automation system like the SCADA, operator actions, etc. into a single database or source of truth. We process these data continuously by comparing them with models of the plant, which we call our digital twins. We then use machine learning and predictive models to create wisdom by comparing the digital twins with the real plant data and deliver this wisdom to the plant as operator instructions or autonomous set point management for the plant. How we deliver it is essentially by helping our customers achieve this journey of taking their existing plants to what we call the smart plant of the future. This is done through a combination of digitalization steps as well as implementation of the Industry 4.0 design concepts through our 3 tiers of product, Connect, Assist, and Operate. The idea is that Connect provides digitization, connection of the operating technology layer of the plant with the IT, and providing visibility through unified web-based dashboards. Then with Assist, we provide elements of transparency and decision support, which are 2 key elements of providing advanced level digitalization guidance based on data analysis, predictive analytics to provide wisdom, process insight, and foresight as operator support or decision support. And then finally, we achieve the last level of automation, which we call adaptive closed loop control or decision automation through our Apricot Operate product. Here is an architecture of a process plant which is perturbed by its local conditions and is managed by the operations team, and it is separated by this vertical line from the management, which often does not have a direct visibility of the plant. IntelliFlux connects an edge device to collect all the sensor data from the plant and puts it in a secure database, which is often located in the cloud. And this is what we achieve with our product Apricot Connect. It just extends the SCADA historian to the web and makes it accessible to everyone in the company. Then we connect the database to what we call our decision engine server, and that decision engine server compares the plant data with models that are called duos or digital unit operations, which are IntelliFlux's developed product suite of unit operations or digital twins for the processes that represent the plant. So we continuously perform this comparison between the actual plant data and the models with our AI, ML, as well as various types of optimization algorithms, and we collect this information into a knowledge base which we call SAGE. Now this knowledge base provides process-specific instructions and wisdom to the operations team at the plant, which is delivered through the edge device and in various devices or screens that are available with the operators. The information from the knowledge base is simultaneously sent to the management team, which could be the sustainability group or the people who are experts at the headquarters of the plant. This allows simultaneous viewing of the data by the operators of the plant and the management. There's a final step that IntelliFlux also achieves in its technology, and that is in the lower left corner. You will see that we deploy Apricot Operate to perform what we call closed loop autonomous set point adjustments. Here we take the same wisdom that we were sending to the operators. This time the information is directly sent to the control system of the plant, the PLCs. This allows you to deliver a fully autonomous autopilot-like operation of the plant. This is the ultimate realization of Industry 4.0 that we achieve. The fundamental mechanism by which we deliver our results in the existing plants and in our technology stack is through digital twin models, which we call DUOs. DUO stands for Digital Unit Operation. These are physics and chemistry based models. They are dynamic, that means they are time dependent and can process transient data. They can be connected to the live data feed from the plants. They provide near real-time comparison between the simulations from the duos as well as and the actual unit operation performance from the plant. These duos can be operated in various modes like the simulator mode, the optimizer mode, and as drivers of the state space models of control. We provide predictive guidance as well as model predictive control by the help of these digital twins. These digital twins also allow us to deploy reinforcement learning in our AI ML components of the software, and the digital twins are absolutely hardware agnostic. We can place the digital twins in the edge, in the fog, and in the cloud. We do not have to worry about the architecture of the computing system. We can put it anywhere for deployment. So what is the rendition of a digital twin? Here is an example of a digital twin or a duo for a UF-MF operation for a single rack. What happens at the real plant is used as design elements to design this digital twin, and then the output of the digital twin is shown on our Apricot platform on our portal, where we can see real-time data, we can see maintenance related guidance, we can see the performance with respect to the filtration system, and any automation that the digital twin is driving for Apricot is also shown as results in this screen, showing what are the benefits, etc. Now the digital twin embeds the dynamics of membrane fouling and can model how the membrane deviates in its permeability from baseline, and that is used to perform various actions like cleaning and CIP of these membranes. Here is another example where we apply the digital twin by embedding the kinetics of biodegradation of carbon, nitrogen, and phosphorus in wastewater in a sequencing batch reactor. In this case, the digital twin shows how the real data from the plant, influent and various conditions, as well as operating data, are compared with the various design parameters. And on these graphs, you are seeing the various performance parameters of the plant being simultaneously compared with the digital twin. We have taken the digital twin technology to one step higher, where we can actually very quickly construct flow sheets of the real plant. In this case, for instance, this complex flow sheet has been mapped into a digital twin, and this is like a working simulation model for the plant with all the process control, all the physics, chemistry embedded into each of these boxes that represent the RO system or the pumps or various unit operations. And you can dynamically put in all the parameters that guide this and then run the simulation and can do scenario analysis as well as drive this digital twin as a driver of the automation system for the plant. For instance, in our RO digital twin models, we have included models of aquatic chemistry based precipitation to provide ideas of pH adjustment or when a scaling will happen to the RO module, as well as how to adjust anti-scalant dosing. Here is a screenshot of the Apricot portal, which basically shows you can open up any dashboard and you can basically see in real time what you're observing with the plant. You can perform higher level of data aggregation and basically show heat maps and other things that provide various types of correlations with weather conditions or upsets or various kind of water quality excursions, etc. And these are mined with our AI algorithm to provide advanced level analytics for the customers. We can run this and see the behavior of the control with the KPIs or key performance indicators, which shows how much enhancement in backwash interval has happened, or what is the savings of cleaning water, what is the savings of energy in these types of operations. We have built very, very interesting types of algorithms to look at how machine learning can be applied to identify the cause and effect relationships between the microscopic behavior of the microcosms in a bioreactor and what is happening with respect to the bioreactor. For instance, in bioreactors, you can have various modes of upsets like foaming, pin flocks, etc. And we have developed AI tools based on convolution neural network that allows you to identify with just an image analysis what could be a potential problem in a bioreactor. Here are a few broad examples of what benefits we give our customers when we go and put IntelliFlux in an existing plant as an upgrade. In wastewater treatment, when we go and deliver it to submerged bioreactor, membrane bioreactor systems, we have often observed reduction in specific energy consumption, increase in filtrate flow rate or yield, and savings in chemicals like bleach and citric acid, and most importantly, a significant enhancement in membrane life. This autonomous operation of these MBRs have extended the life of the membranes by reducing the irreversible fouling of these membranes through intelligent mode cleaning and backwashing. When we apply these to various types of bioreactors, we achieve 40 to 50% less aeration energy demand per cycle because we can match the specific aeration demand for the COD of the system at any given time in the reactor. This allows us to get lower specific energy consumption, higher net treated effluent yield. We have managed to reduce upsets in these reactors quite dramatically, and we can give quite a bit of savings in operating expense for these types of systems. We have also applied this in seawater reverse osmosis systems, and we have increased the overall yield of the seawater reverse osmosis plant by changing upstream behaviors of coagulant dosing, changing the residence time in the multimedia filters, etc., by using antiscalants and biocides, etc., before the RO with remarkable effects. In these cases, for instance, in this plant, there was a huge problem which led to fouling of the RO modules and cartridge filters. Before we installed IntelliFlux, this plant was replacing cartridge filters once every 4 weeks. Once we went into this plant, the cartridge filter replacement time became 10 weeks overnight after IntelliFlux started taking up the operations. That's led to a huge OPEX saving. Moreover, the RO plant operator was actually able to get advanced notifications up to 3-4 hours in advance when there was an influent water quality surge or water quality excursion that happened. This allowed the operator to manage the reverse osmosis plant's fouling behavior with a lot more confidence and effectiveness. The key results that we obtain when we deploy a digitalization solution like with Apricot, we get across the board significant savings in clean water use, energy use. We have reduced the number of employees who are working at the plant site, and when we have membrane operations, we have increased the modular cartridge life replacement interval quite dramatically. The big benefits when we go to these brownfield retrofit plants is that these plants normally show a depreciation, and their cost for operating increases, which basically means that their profit margins reduce over the life cycle as the plant life increases. So when we introduce Apricot to these plants at a later stage of their life, we see an increase in the efficiency of the plant, which translates into better operating cost management for these plants and an extension of the life of the plants. So these manifest as a variety of improvements for the plants over the remainder of its life, and it increases the plant's commercial and lifetime project value. IntelliFlux provides an amazing opportunity for process industries where our customers both have existing plants where they can deploy IntelliFlux as a retrofit upgrade. Then when they are convinced about the benefits of IntelliFlux with their existing plant, a lot of them specify IntelliFlux as the automation code developer for their new plants. And with appropriate engineering decisions and coding, we can develop the smart plants of tomorrow where we reduce the upfront automation integration efforts by about 70%. We deploy the digital twins from day one, and we can deploy the full mode of Industry 4.0 smart process plant control philosophy in these plants. Our closing thoughts about this should touch a few challenges that are still needed to be addressed for future deployment of these and for full implementation of autonomous smart plants. These are: you need a systems engineering approach. Only water treatment engineering will not work. We need process control, automation, sensor technology, data science, everything to collaborate to develop the codes for the future plants. What will be the leading technology in automation? There is a little lack of clarity still today, whether it will be digital twin, physics-based modeling, or machine learning, which is data-driven modeling. So far, we understand that data-driven modeling provides results much more slowly, and it consumes a lot more data than a digital twin-driven model for process control. We don't know what level of autonomous plant operation is acceptable in industry and society. We see variations in different countries, different regions. So there needs some societal acceptance for making these plants completely autonomous. We have a huge concern about cybersecurity and risk management when you have autonomous plants. And finally, we don't exactly have consensus on whether fully autonomous plants are more or whether they are less reliable than human in the loop system. In conclusion, however, one of the things that is becoming totally clear is that the modern process control and smart automation will involve this basic closing of the IDKW loop in a device agnostic way so that people can reach the data, understand the analysis of the data, and find out solutions from anywhere, anytime, and most likely as quickly as possible. Thank you for your attention, and I'll be very happy to take any of your questions, and you can definitely contact me. Thank you very much.